This is the third video segment from the current series that I'm making. Let me remind you what the problem was that we were considering. It was a winding block like that. This right end is clamped, and on the front face, I have several features. A circular one where it's going to be clamped, a rectangular one where there is a force applied on it in a certain direction, and the square feature where a pressure is being applied. In the previous video segment, I did this problem using the default four-noded octary tetrahedral elements, basically free meshing. What I want to do now is do this problem with break elements. Break elements are not standard elements in Catia, therefore you have to do some work in order to get to a mesh like this, and that's where we're going to do it in. That's why we're going to do it in the advanced meshing tool. Anything beyond the standard four-noded and 8-noded tetrahedral elements have to be done using advanced meshing tool. Okay, so as I did in the previous section, I created the model, and I'm going to repeat that because there is one minor difference, and I think you're gonna benefit from it. Okay, so let's go here, and by the way, the geometry of this object, was based on a ribbing operation of a square 40 millimeter by 4 millimeter cross section, which is ribbed along that center line defined by a spline. Okay, the control point for the spline, there's 4 of them: this point, that point, that point, and that point, and the coordinates are given. So let's go ahead in Catia, and on the vertical plane, I will sketch. I will sketch a square 40 millimeters by 40 millimeters. So this is going to be 40, and here is going to be another 40. Okay, and then exit. On the XY plane, the horizontal plane, I will draw that spline center line. A sketch. Now, if you look at the previous video segment that I created the same model, what I did, I created 4 points, and then made the spline go through those 4 points. And those 4 points that I created individually, I had to turn them into construction elements, because otherwise Catia will complain. It says that you cannot rivet along that spline because the sketch is open. Now, what I'm going to do here is I'm not going to create those points directly, but as I do this spline, I will input the appropriate coordinates. So here's the spline. Notice that which is right, let me see for a second, which is right there. You click on it, and then you can type the coordinates of the control points here. First point, then you have the next one is 40 and minus 5, 40 for x, millimeters or millimeters, minus 5. The next one is 80 and minus 15, 80 millimeter and minus 15. And the last one is 160, and tab minus 20. Okay, so there we are, and we're done. So escape, so that the spline is released. So exit, and now we're gonna rib this. Now, ribbing operation is not in the generative shape design. It's in part design. Make sure you're in part design. Get the rib right there. Rib. Let me cancel that. Okay. So the profile is this square, and the center curve is that spline that you created, and we're going to say okay. All right. Now this was done in the other video segment, the earlier one, but because I created points first, and then let the points pass through those, the spline pass through those points. I have to turn the points into a construction entity. Good. Now, what we like to do is we're going to extract the side face and the back face, and that can be done in generative shape design or wireframe and surface design. Here's the extract icon. So we're going to select this, the front one, okay, and then extract the back side, okay, right there, okay, good. Now, the next thing is to create our sketch, which we're going to project. So these steps are identical to the previous video segment. So we're going to create a plane offset from the XZ plane by 30 millimeters. Okay, and on that plane we will sketch. Those features similar to the things that you saw in the slide. So there was a circle here, right? The circle here. Eventually, that's going to be clamped. The area within that circle is going to be clamped. There was a rectangle here. Eventually, there's going to be a force acting on that. And finally, there's another feature here, which is looks like a square. And we're going to put a pressure on this. And exit. Okay. The next step was to project these onto that face. So look, you're in generative shape design, look for projection. There's the projection, you can see that right there. You select that sketch. Now, if the nearest solution box is checked, then only the piece of the sketch which is closest to that support is going to get projected. But if you want everything to be projected, make sure this is unchecked. And for the support, you select that surface over there, and then we say OK, and keep all the sub elements. And there we are. You can see that right there. These steps, as I said, are identical to what we did before. Let me hide this sketch. Good. I don't need this plane either, so I'm going to hide it. The next step was to fill this projection. This projection. So fill is right there. You select the projection and keep all the sub elements. So now we actually have surfaces bounded by this square, bounded by that rectangle, and bounded by that circle. And don't forget to sew. Sewing is not here though. Sewing is in the part design. You go there, look for the sew right there, sew surface, and the surface is exactly what we did, the fill, and make sure the arrow is pointing into the object, and make sure you uncheck the simplify geometry, and we say OK. All right. Now these features are created. As a matter of fact, if I hide that extract, hide it right there, notice that these surfaces are sitting there. These are the fills that we did after we projected them. Okay, so what is the next step? First, let's save everything. File, save management, save as, break element right there. We're going to save it as part 1. Okay, very good. So, okay. Now, let's apply material here, by the way. So it's right, apply material is right there. You select metal, aluminum on that part, and we say OK. All right. The next thing is we are going to this surface that we extracted. We're going to mesh it with nice square type elements. Okay, so in order to do that, you have to go to anything fancy. You've got to go to advanced meshing tools, and there are different ways of doing it. Okay, so you go there. Okay, So notice that for creating surface measure, you have the surface measure, advanced surface measure, and the standard one that you have uh, in uh, in generative structural analysis. Okay, so we don't want this. We're going to use surface measure. Okay, you select that face, this side face that we extracted. I told you that we need that in this video segment, but not in the earlier one. Okay, so we're going to use all, the shape is going to be all only quads only quads only, and I'm going to put 5 mm. So this basically is going to be broken into rectangles or squares of 5 by 5. So we say okay. Okay, now you have to mesh it. You put the cursor there. You see that? You put the cursor on this. It says mesh it. And there we are. So these are each 5 mm. Remember, this was 40, so it's 80 this way, 8 that way. And when you're done and you're happy, you exit the surface measure. Good. Okay, now when you look at the three-dimensional elements, let me open this up. And you have to do that in advanced meshing too. These are the standard tetrahedral elements, four-noded or quadratic. And this one is called sweep 3D. Sweep 3D means that you have a two-dimensional mesh like that, shell mesh, and you're going to sweep it in a certain direction so that it fills the object. So you can click on that. So it says, if you look at you read the prompt here, it says select the volume to mesh. Obviously, this is the volume. Select the bottom. Bottom means one end. That's this. Select the other end. Top means this end. Okay. And for the number of layers, you go to second tab. Number of layers, I put down 20. Okay. And you can do it uniformly or arithmetic progression or geometric progression, but we want a uniform mesh. And we say, okay. Sorry, let me see for a second what happened here. Okay, cancel that. Let me do it again. Let me double click on this. Okay, so apply. I should have said apply. There we are. I just said okay, so I should have said apply. And we say okay. There we are. Now, in the next video segment, notice that sweep requires a volume because you're going to be sweeping along that volume. The next video segment, there is no volume. There is no basically geometry. Here I have a geometry that I'm using for sweeping purposes, okay? In the next video segment, you have basically an orphan mesh. You create an orphan mesh. There is no geometry associated with it, and there's some subtle differences between those and the problem that we're doing right now. Okay, now make sure that first of all you deactivate the surface mesh. The sole purpose of the surface mesh was to be able to sweep it. Once we are done, we're going to deactivate it. You put the cursor on it, right click, deactivate. We no longer need it. The other thing is that these elements that we created, notice that there is no properties associated with them. Properties is none. So you go to the generative structure analysis, because I don't think we can apply properties here. Let me see for a second. There is, can't do properties here, so you go to switch workbenches, you go to generative structure analysis, and the properties is right here in the model manager toolbar. This is a 3D property. You click on it and it says, okay, where's your element? Well, it's the sweep element right there. Notice that there is no material here, nothing is defined, but as soon as I go and select that sweep, that turns into aluminum because it goes to that part. All right, good. You can actually look at your mesh here, put the cursor there, right click, mesh visualization. It's the same mesh that we got before, and deactivate it to do the rest of the problem. Deactivate. Okay. Now, notice that there was a surface here that I hid, okay? And in fact, none of these things, I need them anymore. Okay, and right, none of these things I need them anymore, so I just hit it. Let me undo it. These are the surfaces. These are the fill operation that I showed. Right click, hide. Okay, there are features created here. You can see that I can pick it. You can actually pick these things. Okay, and I'm going to hide this end surface that was extracted to. Remember, the sole purpose of that was to be able to measure it and then doing a sweep operation. Okay, now let's see. Now this is clamped, right? So you select a clamp on that end face. It puts this. And if you want, you can also select from here. It puts it on both of them. Okay, or you can do that separately. These two faces are clamped. So we have a force applied on that feature in the direction Y, or any direction that you want. I put down Y, and it's going to be minus 500 Newton. I think in the statement of the problem, I said 500 Newton. If you want, you can change these units to Newton. Okay, I'm going to do that actually. Let me go to Tools, Options. Okay, under Parameter and Measure, under Unit, the force I'm going to change to Newton, and the pressure to Pascal or kilopascal. Okay, pressure to kilopascal. Do I have it here? Pascal. My God, there's a kilopascal. If you look at your force now, it should say 500 in the direction Y, negative 500 direction Y. Okay, good. Now we apply pressure on this feature, and it was 500 kilopascal. We say okay. All right, hopefully we didn't forget anything. We're going to save that. File, save management. There's the analysis file. Save as. In the same folder, analysis 1. We say okay. And assuming we didn't forget anything, and I don't think we have, we're going to run it. Say okay. What does this say? Well, let's go ahead and see whether it looks right or not. Okay, good. So deflection looks like so. That makes sense. Okay, deflection looks like so, and you can animate it. Okay, nothing surprising. Let's look at the von Mises stress. Yeah, that makes sense. And change this into material shading. And if you want to see the elements, go to your rendering again, and with this question mark down here, you click on it and the elements will pop up. Okay, so that makes sense because we put a clamp here, a clamp at the end, force here, and pressure there. Now, if you say that, okay, well, why don't I go on? I can't see this basically. I can't see this. So let's put a 5,000 Newton and run it 10 times more. Okay, it's going to be a big blob down of red down there probably. Activate this. Okay, change the scaling to default. Scaling is down here. Amplification factor. There we are. So there's more pronounced. There's no more pronounced red area here. Now, the other thing I was going to tell you is that if you want to look at, because these clamps are taxing the rest of the structure, what we can do, if you want, you can create a group here. Let me deactivate that. Okay, so let me create a group and put my group in this section, excluding the excluding these clamp areas. So let's create a box group, okay, and let's position it. Let me position it right there, okay, and resize it. Let's concentrate on this middle section, okay, about the middle section will make you, okay, maybe a little bit more. Let me say okay, and activate the von Mises stress, and go to the click on the von Mises stress, and on the selections tab, select the box group. There we are, and hide this. Okay, you can see there's the big blob of red that I was talking about. Okay, my group was not big enough, that's why I just took some of these elements away. So let's go ahead and do that. Let me show that first. Hide it, hide and show. Okay, so notice that I did cut off some of these things. So double click on it, resize it, grab this and make it go this direction. Okay, so it's covering more area now, and deactivate this and hide it. There. I promised that there was a red blob here because you're applying 5,000 Newton. That's a lot of force, but we couldn't see it because of these clamps taxing the rest of the graph. Now, one last thing that I want to do here, let me deactivate this, deactivate that. And if you, for example, look at this distributed force over here, if you put the cursor on it and you say, show me how the forces were actually distributed on that piece, you go to at the bottom, distributed force visualization on mesh. You click on it, and it's kind of hard to see here. Let me change this thing to a different rendering, to wireframe. There, you can see that. That 5,000 Newton was divided in a consistent way on that rectangular patch. You can see that there's some very tiny small arrows here. So this distribution is statically equivalent to the total force of 5,000 Newton in that direction. You can do the same thing with the pressure here. The pressure, you put the cursor on it, right click, pressure visualization, and if you look at it carefully, for the case of pressure, this is all uniformly distributed because the pressure, and therefore it's going to be 500 on those faces. Okay, but anyway, this is all done. The final segment for this particular sequence of video tutorials is that I will not have a geometry, a solid part associated with my model anymore. Okay, so I'll have a mesh, I'll create a mesh where there is no solid part associated with it, therefore you cannot sweep it, and there are some subtle differences between how it's done there. The same problem is done there, this kind of a problem is done there, and when you have a geometry and you sweep it. I will not use the same geometry though. I might get the straight beam because it's easier, there's less work involved in showing you the steps. Okay, have fun.